cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
For centuries, humanity has gazed up at the night sky and dreamed of traveling beyond the stars. From ancient myths to modern science fiction, the idea of journeying to distant galaxies has captured our imagination. But there's one cosmic speed limit that has always stood in our way: the speed of light. It's the universe's ultimate barrier, a fundamental constant that seems to lock us within our own tiny corner of the cosmos. But what if that barrier wasn't as unbreakable as we thought? What if we could shatter it? In this video, we're going to explore what faster-than-light travel could actually look like, delving into the mind-bending science and the profound implications it would have for all of us. We'll look at how it might be possible and how it could change, well, everything. So buckle up, because we're about to take a journey to the very edge of physics and imagination. To really grasp why faster-than-light travel is such a monumental concept, let's talk about scale. The universe is unimaginably vast. The nearest star system to us, Alpha Centauri, is over 4 light-years away. That sounds close, right? But if we were to send our fastest current spacecraft like the Parker Solar Probe, it would take over 6,000 years to get there. To reach the center of our own Milky Way galaxy, you're looking at tens of millions of years. The distances are simply too great for a human lifetime. But if we could travel faster than light, this cosmic isolation would end. A trip to Alpha Centauri could take weeks or even days. Crossing the entire galaxy might become possible within a single human lifetime. Entire new worlds, potentially habitable planets, and untold cosmic wonders would suddenly become reachable. This isn't just about satisfying our curiosity. It's about securing the future of humanity, expanding our horizons, and fulfilling our species' ultimate dream of becoming a truly interstellar civilization. So, how do we break this cosmic speed limit? This is where we run into one of the most famous figures in science, Albert Einstein. His theory of special relativity states that as an object with mass accelerates, its own mass increases, requiring more and more energy to go faster. As it approaches the speed of light, its mass would approach infinity, requiring an infinite amount of energy to push it past that barrier. Essentially, nothing can travel through space faster than light. That seems like a dead end, right? But here's the brilliant loophole that physicists have been exploring. What if we don't travel through space? What if we bend space itself? This is the core idea behind a warp drive, most famously theorized as the Alcubierre drive. Imagine your spacecraft is inside a bubble of space-time. The warp drive would compress the fabric of space in front of the ship and expand it behind. The ship itself isn't moving faster than light within its local bubble. It's just riding a wave of space-time. It's like standing on a surfboard. You aren't moving faster than the wave, but the wave itself carries you across the ocean at incredible speed. This ingenious concept doesn't technically break Einstein's laws, but it does find a clever way to work around them. Now, you might be thinking this all sounds like pure science fiction, something straight out of Star Trek. And for a long time, it was. But surprisingly, the science behind warp drives is being taken seriously. NASA has funded research through its Breakthrough Propulsion Physics program, and independent researchers and physicists around the world are actively exploring the theoretical models that could make it a reality. The biggest hurdle has always been the need for something called exotic matter, or matter with negative mass density. This is stuff we've never observed and don't know how to create. It sounds like a showstopper. However, recent theoretical studies have proposed new models that might reduce the insane energy requirements, potentially even eliminating the need for negative matter altogether by manipulating the geometry of the warp bubble. We are still a very, very long way from building a functional warp engine in a lab, let alone on a starship. But the crucial point is that the door, once thought to be firmly shut by the laws of physics, is now slightly ajar. The research is pushing the boundaries of what we believe is possible. Let's allow ourselves to dream for a moment. Imagine a future where faster-than-light travel is real. What would that mean for human civilization? The consequences would be staggering. For the first time, colonizing other star systems would move from the realm of fantasy to practical engineering. Humanity could expand beyond our home planet, establishing outposts on exoplanets orbiting distant suns. This would ensure the long-term survival of our species, making us resilient to any catastrophe that might befall Earth. But it goes deeper than that. Trade, culture, and politics would become interstellar. We might have trade routes carrying resources from one star system to another. New cultures would emerge, shaped by the unique environments of new worlds. Our entire perspective would shift. The universe would no longer be an unreachable, mysterious void that we can only observe from afar. It would become our backyard, our new frontier, a vast and open territory for exploration, discovery, and settlement. It would be the single greatest transformation in human history. But with great power comes great risk, and breaking the light barrier would undoubtedly be the greatest power humanity has ever harnessed. The dangers could be as profound as the rewards. For one, arriving at a destination at superluminal speeds could release a devastating blast of energy, potentially sterilizing the very planet you intended to explore. There are also paradoxes to consider. While a simple warp drive doesn't allow for time travel to the past, more complex manipulations of space-time could open up that can of worms, leading to causality violations that could unravel the fabric of reality as we know it. And then there's the biggest unknown of all. What or who is out there? By venturing into the galaxy, we might encounter cosmic forces beyond our comprehension, or even civilizations far more ancient and advanced than our own. Would they be friendly, indifferent, or hostile? Traveling faster than light could reshape not just our future and our place in the cosmos, but our very understanding of reality itself, forcing us to confront questions we're not yet prepared to answer. So, is faster-than-light travel an inevitable destiny or an impossible dream? For now, it remains firmly in the realm of theory. It is a monumental challenge that will require breakthroughs in physics that we can currently only imagine, but we should remember that throughout history, humanity has a remarkable track record of turning dreams into technology. The idea of flying was once a fantasy. Journeying to the moon was science fiction. Yet we achieved them. The quest for FTL travel pushes us to ask bigger questions, to challenge our assumptions, and to innovate at the deepest levels of science. Maybe one day this dream, too, will become a reality. Perhaps our descendants will look back at our time as the dawn of the interstellar age. The stars feel distant now, but they may be closer than we think. Thank you so much for joining us on this journey to the edge of possibility. If you enjoyed this exploration of science and the future, be sure to hit that like button and subscribe to the channel for more content that pushes the boundaries of imagination. We'd love to hear your thoughts in the comments below. Until next time, keep looking up.